Hey, welcome back. Today's lesson, we're going to talk about scientific notation. And a lot of you guys probably have some experience with this from science. Hey, welcome back. Today's lesson, we're going to talk about scientific notation. And a lot of you guys probably have some experience with this from science class, but we're going to give it a try here in math class as well. Scientific notation is used to describe either really, really great big numbers or really teeny, 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 tiny numbers. And there's a special form for scientific notation, and it looks like this. It's some number times 10 to a power. Now notice there's two parts to that. There's this first part and then the exponent part. The first part here, there's a certain range of numbers or a certain size that first number can be. This has to be a number between 1 and 10. Okay? And this number up here, the exponent, a lot of times people say or think that that's going to tell us the number of zeros there are in the answer. Well, that's not entirely true. Sometimes it's true, but not always. This number up here tells us how many times you move the decimal point. Okay, how many times you move the decimal. Now that exponent can be positive or it could be negative. Kind of one easy way to help us remember that is that exponent there is going to be a positive number when we're talking about really, really big numbers. Okay, like, well, just big numbers, the distance to the moon, thousands, millions, billions numbers. Okay, the exponent is going to be a negative number when we're talking about really, really small numbers. Okay, maybe the width of a cell. Just really, really, really small things. Okay, and so maybe I'll write this also here. Okay, this is describing what kind of an exponent we're going to have up there in the power of 10. But there's two parts. Okay, we're going to do 4 different things here with scientific notation today. We're going to convert from scientific notation to standard form to scientific notation, and then we're going to do a little bit of multiplying with scientific notation and a little bit of dividing with scientific notation. Okay, so here's our first thing that we're going to take a look at. I have a couple problems here that we're just going to convert them into scientific notation. Okay, so we're going to change each one of these into some number times 10 to a power. Okay, and I talked about this first number having to be between 1 and 10. Well, obviously that's a really big number, 1,925,000. It's way bigger than 10. Okay, and I talked about moving the decimal point a few minutes ago. Well, I didn't even see a decimal point on that number. Well, if we have a regular number and there's no decimal point there, we know it's always at the end. Okay, and I need to move it so that it changes that big number into a number that is between 1 and 10. Okay, and I think if I move that decimal point right to here, so that number becomes 1.925. That's where it would have to go, so it is a number between 1 and 10. Okay, and then I need an exponent up here. And I talked a minute ago about, well, that tells us how many times we move the decimal point to get to that spot. It started over here at the end, and I moved it 1, 2, 3, 4, 5, 6 times. I moved it 6 times. And sometimes people run into an issue and they're trying to decide whether is it a positive 6 or a negative 6. And I've seen people say, well, when I move it to the left, it's a positive exponent. When I move it, let's suppose it's started here and you guys counted this way, it's a negative exponent. It gets to be all messy. Again, I'm going to back up one screen. If I go back to what I said a couple seconds ago about this part right here, this is a really simple way to keep track of what kind of an exponent we're going to have. Okay, I believe the number we have there is 1,925,000. That's a really big number. Really big numbers have what kind of exponents? Positive exponents. So that's going to remain a positive 6th power. Okay. The second one here, that has to be written as some number times 10 to a power. And notice I automatically write those two parts right away. I think it keeps it nicer. Okay, I don't see a decimal, so it's right here. If I move it to a number that's between 1 and 10, it's going to go between the 4 and the 2, so 4.26. And oftentimes it's always right after the first digit. Okay, and how many times did I move it? 1, 2, 3, 4, 5. Should it be a positive 5th power or a negative 5th power? Well, the number I started with was 426,000. That's a big number. We're going to keep it positive. Okay, so this isn't too bad. There's not a lot of work to show. Okay, if I scroll down here just a little bit further to these bottom two, oh, here I have something different. Okay, I need a number, obviously that's too little. That's a really teeny tiny number. And I need to move the decimal point so that it ends up between 1 and 10. And I think the place I'm going to put it is right there after the 4, 4.23. Okay, and I'm going to count again. How many times did I move it? 1, 2, 3, 4. It's a fourth power. But when I go back and look at that, the number that it started as 0.000 or 0.000423 is a really teeny tiny number. Teeny tiny numbers have negative exponents. Okay. All right, last one here. Ooh, this one always catches people a little bit. 25 billion. Ooh, we need to write that out. And by the way, these numbers up here are in standard form. Can I write 25 billion in standard form? Okay, well, I'm going to start adding some zeros. There's 25,000. After the thousands, that's 25 million with an M. And I think if I add 3 more zeros, I think there's my billion. 25 billion. Okay, and if I want to change that number into scientific notation, okay, I think my decimal point has to go right here after the 2, so 2.5. It starts there at the end, and if I count, I can kind of lump these together. I can do 3, 6, 9, 10, the 10th power. Okay, and it's a positive 10 because 25 billion is obviously a really big number. Okay, and notice again, it's the number. The exponent is the number of times I move the decimal. Some people say it should be 9 because it has 9 zeros. Nope, it's strictly how many times we move the decimal point. Okay, so what we did on these 4 is we converted them from standard form into scientific notation. On the next screen here, we're going to go backwards. What if I have a couple in scientific notation? Can I change these guys into standard form? Okay, well, there's my decimal point. I try and find that first. And then I look at the exponent, the 6th power. That means I'm going to move that decimal point 6 times. Okay, and because it's a positive 6, I need to make that number bigger. 5.36 bigger. The way I make those numbers bigger, a number bigger, is I move it to the right. And I'm going to move it to the right 6 times. 1, 2, 3, 4, 5, 6. And these little bubbles get filled with zeros. So it's a 5, 3, 6 with 4 zeros. It doesn't have 6 zeros. It has 4 zeros. And if I want to go back and put in my commas, that would be 5,360,000. Okay? All right, same thing over here. 4.02. I see a negative 3rd power. The 3 there tells me I'm going to move the decimal point 3 times. But because it's negative, I need to make that number smaller. And the way I make a number smaller is I move them to the left. I'm going to move it to the left. 1, 2, 3. And again, those bubbles I fill in with zeros. It's 0.00402. Okay? And we do need to make sure that we write all the other numbers here. The only time I wouldn't have to write extra numbers is if I had zeros after the 2. Okay, but I don't. But I have to go out at least to the 2. Okay, and lastly here I got 1.82 times 10 to the 5th. This is a positive 5th power. Means I'm going to move it 5 places to the right. And I'm going to end up with 3 zeros. 182, 1, 2, 3. 182,000. Okay, and don't try and do too much in your head. Don't hesitate to draw the little bubbles and count them. Okay, it's really, really helpful for you to see it by drawing the little bubbles. Okay, so again, going back and forth from standard form to scientific notation to standard form, hopefully it's not too terribly bad. Okay, the third thing, as I mentioned earlier, we're going to do a little bit of multiplying here in scientific notation. Okay, calculator might be helpful a little bit here. Now, there's a couple different ways to do this, but I'm going to show you kind of what I call the shortcut. Okay, instead of changing this to standard form by moving it 6 places and moving that 5 places, multiplying 2 really big numbers together, and then rechange it into scientific notation, here's a little bit of a shortcut. Okay, we're multiplying here. The shortcut is we're going to take the decimal pieces, and we're going to multiply those 2 things together. Okay, I'm going to do 1.5 times 2.3, and I'm going to get 3.45. And but all these things are just being multiplied together, so I can multiply things in any order. But I'm going to multiply those together, and then it's going to be times 10 to some power. Well, what I have here is I have 10 to the 6th times 10 to the 5th. And one thing we learned a while ago with the properties of exponents is that when I have two numbers and the bases are the same, I multiply them together, I add the exponents together to the 11th power. Okay. What I did up here is I added the exponents on the 10. So 3.45 times 10 to the 11th. One thing we always have to go back and check here real quick is always double check that number right there. Is that number still between 1 and 10? And 3.45 is between 1 and 10, and we're done. Okay, so it's kind of a nice little shortcut. Okay, got a couple more here. How about this guy? If I multiply these decimal pieces together, 3.5 times 1.6, I get 5.6 times 10, and don't forget the second part, times 10 to which power? Well, I have a 4 and a negative 7, and like I said up there a minute ago, we're going to add the two things together. 4 plus negative 7 is negative 3. Is it okay to have a negative exponent in scientific notation? Sure is. Is this number right here between 1 and 10? 5.6 is. We're good to go. Perfect. Okay. All right. Now I have two special ones down here. Let's do one at a time and let's see what's special about them. Maybe I'll switch that up a little bit. Okay. I'm not going to do anything different. Let's do the same thing that we have been doing. If I take 3.5 times 7.2, 3.5 times 7.2, I'm going to get 25.2 times 10. And if I take my two exponents and I add them together, I get the 7th power. Okay. Didn't do anything different, but look at this right here. Is that number between 1 and 10 still? No, it's too big. Okay. Where should that decimal point go, or where do we want that decimal point to go? We want it to go between the 2 and the 5. Okay. So it should be 2.5 times 10 some power. Well, I had to move the decimal point over one more time. What does that do to the exponent? I add one more onto it. I add one more onto it, and it becomes 10 to the 8th power. Okay. So if the number's too big, and I have to move it one more time over to the left, I add onto the exponent. Okay, now that's good, and we're good. Okay, I got one more here. Whoops, way down here at the bottom. Can I do it one more time? 4.3 times 5.5. If I grab my calculator, 4.3 times 5.5, it's going to tell me 23.65. And again, I have a couple negative exponents. Is that okay to have negative exponents? Sure can. But like I said before, we're always going to add the two exponents. And negative 2 plus negative 5 is negative 7. Okay? Now, so far so good. But again, I go back and I look at this part. Oh, that's too big. 23.6 is way bigger than 10. Okay? We want that decimal point to bump over one more time. So it should be 2.365 times 10 to some power. And I just had to move it once. So I would add another one on to my exponent. Now be careful. Some people make silly little mistakes here. What's negative 7 plus 1? Is it negative 8? Nope, not negative 8. Negative 7 plus 1 bumps it up to negative 6. So when those exponents are negative, you got to just be careful with your addition when you're adding one onto it. Okay, so that's kind of the little shortcut of multiplying two numbers that are in scientific notation. Okay, the last thing I have here is dividing numbers in scientific notation. Okay, and notice how the division is written as a fraction bar. Okay, we usually don't see things written with that division symbol. Division is going to be written as a fraction bar. Well, we can do the same exact type of shortcut. I can divide the decimal pieces. I can do 4.5 divided by 1.5, and I get 3. Turns out to be a nice number, times 10 to some power. Well, also, like we talked about a few days back when we did these properties of exponents, if I have some on the top and I have some on the bottom, I subtract them. 8 minus 10, it's always the top minus the bottom. 8 minus 10 is negative 2. So I get the negative second power. 3 times 10 to the negative second. And if I do my little check here again, now there's no decimal in that 3. That's okay. Is 3 between 1 and 10? Yep, it's perfectly fine. Okay, but again, the rule is we're going to divide the decimal pieces, and this time we're going to subtract the exponents. And once again, it's always the top one minus the bottom one. Okay, and with scientific notation, it's okay to leave our answers with negative exponents. Okay, I've got a couple more here. How about this one? A little bit bigger decimals, bigger numbers. Let's try 3.006 divided by 7.3. What does that give us? Oh, that's not very nice. Okay, it's a big long decimal, but I'm going to round it off to 0.41. 0.41. There's some extra stuff, but I'm going to round it 2 decimal places. And how about this? This actually was a special one also. I should have labeled it. If I do my exponents, 8 minus 5, I get 3. Okay. But I'm going to go back here. 0.41's too little. It's not between 1 and 10. The decimal point we want it to go, or we want it to be right between the 4 and the 1. Okay, and maybe I'll even write that out here. This one's a special one also. Okay, and it's special because that number's too little. Well, when it was too big a minute ago, we added onto the exponent because we had to bump it to the left one more time. Well, probably what you're thinking right now, if I have to fix my answer because it's too little and I have to bump it to the right, we're going to subtract 1 off the exponent, so I get the second power. And now that's between 1 and 10, and we're in business. Okay, so we're going to do the same thing. We just, again, always have to check that decimal part. Okay, here's one last one I have for us. Okay, let's divide these numbers. So I have 2.3958. Oops. 2.3958 divided by 1.98. And I get 1.21. And if I subtract these, 3 minus 8 is negative 5. Okay? Again, top minus bottom. If I look here in the middle, that number's 2. Oh no, that one's perfectly fine. I don't know what's special about that one. Must have did those out of order. That's okay. This one isn't any special. Is that okay? 1.21? Yep. And there we got it. Okay. So sorry about the little confusion there at the end, but yeah, division properties of exponents, multiplication property, of scientific notation, couple little shortcuts, converting back and forth. Hopefully it wasn't too bad. Good luck.